When you're 350 feet above the ground, as you are in the King's Chamber, that won't do at all. I don't know how they did it. All I know is they did it. I don't think anybody knows how they did it, how they lifted those stones, how they brought them up to that level. I think we're looking, again, at a lost technology.
For more than 4,500 years, it has stood almost impossibly still, while entire civilizations have risen and fallen around it.
The recent findings from deploying this technology are nothing short of mind-blowing, because what's been discovered is that there are huge structures coming down from the base of the pyramid deep into the bedrock.
The Great Pyramid of Giza dominates the edge of the Egyptian desert just outside modern Cairo, towering over a landscape that has fascinated explorers, engineers, and historians for centuries. It remained the tallest human-made structure on Earth for nearly 3,800 years. Even today, despite satellites, skyscrapers, and supercomputers, the pyramid continues to challenge our understanding because the sheer scale of what was accomplished still inspires disbelief. So, what happened when scientists asked Grok AI who built the pyramids? Stick with that question, because there's more to the mystery of the pyramids than what catches the eye at first. The greatest mystery ever built. Originally standing approximately 481 feet tall, the Great Pyramid was constructed using an estimated 2.3 million limestone and granite blocks, many weighing several tons, while some of the massive granite beams above the King's Chamber exceed 60 tons each. Those beams were, it is said, quarried near Aswan, more than 500 miles to the south, then transported along the Nile before being hauled onto the Giza Plateau. The logistics alone are staggering. Even with modern machinery, coordinating the extraction, transportation, shaping, and placement of millions of stones would be an enormous undertaking. At the heart of the pyramid lies the King's Chamber, constructed almost entirely from enormous blocks of red granite. Above it sit 5 narrow spaces known as the relieving chambers, first discovered in stages between the 18th and 19th centuries by explorers including Nathaniel Davison and Colonel Richard William Howard Weiss. These hidden rooms have fueled endless fascination. Several of the granite beams are visibly cracked, leading some researchers to wonder whether they fractured during construction, under the tremendous pressure of the monument, or long afterward. Then there is the precision. Surveyors have long marveled at how accurately the Great Pyramid aligns with the cardinal directions. Its sides face north, south, east, and west, with an error measured in mere fractions of a degree, while its foundation is remarkably level despite covering more than 13 acres. Modern laser surveys have confirmed that many joints between blocks remain astonishingly tight, sometimes separated by gaps thinner than a credit card. Such accuracy has prompted generations of engineers to ask exactly how the ancients achieved this level of precision using copper tools, stone hammers, and wooden sledges. That uncertainty has transformed the Great Pyramid, something few ancient monuments become: a canvas onto which every generation projects its own ideas. During the 19th century, some writers insisted the pyramid encoded divine prophecy or hidden biblical messages. Later came theories claiming it concealed advanced mathematical knowledge, astronomical maps, or even measurements of the Earth itself. Engineers proposed forgotten construction techniques, while geologists questioned long-standing assumptions about nearby monuments. Authors such as Robert Bauval argued the pyramids reflected the stars of Orion's belt. Robert Schoch suggested geological clues hinted at a much older Sphinx. Graham Hancock proposed the existence of a forgotten Ice Age civilization. And Christopher Dunn imagined the pyramid functioning as an enormous machine. Eventually, some suggested that visitors from another world may have provided knowledge beyond human capability, but there is also a fairly mundane explanation for the monuments. The builders we thought we knew. Long before these other theories, archaeologists believed they had already solved the mystery of the Great Pyramid. Their conclusion was surprisingly straightforward. The monument was built during the reign of Pharaoh Khufu, also known by the Greek name Cheops, the second ruler of Egypt's 4th dynasty. Around 2560 BCE, Khufu inherited a kingdom that had already mastered pyramid construction through the experiments of his father Sneferu, whose bent pyramid and red pyramid at Dashur revealed decades of engineering trial and error. For decades, critics argued that there was little direct evidence connecting Khufu to the monument itself. Then, in the 19th century, explorers forced their way into a series of narrow chambers hidden above the king's chamber. Inside, Colonel Richard William Howard Vyse and his team discovered red ochre quarry marks left by ancient work crews. Among them appeared inscriptions bearing the name of Khufu, including references to construction gangs such as the Friends of Khufu. Perhaps the most remarkable discovery arrived more than 170 years later. In April 2013, French Egyptologist Pierre Tallet announced the translation of ancient papyri uncovered at Wadi al-Jarf on Egypt's Red Sea coast. Among them was the diary of an official named Merer. He was the inspector responsible for transporting limestone. Written during the 27th year of Khufu's reign, the journal describes crews loading fine white limestone at the quarries of Tura, floating the massive blocks along the Nile through an intricate canal system, and delivering them to Akhet Khufu, the ancient name of the Great Pyramid. It is the oldest surviving papyrus ever discovered in Egypt and provides an extraordinary first-hand glimpse into the logistics behind one of history's greatest construction projects. Although Merer never describes the pyramid's final assembly, his account confirms that thousands of workers were supplying building materials directly to Khufu's monument. Archaeology has also revealed something equally important beneath the desert sands. Beginning in the 1990s, excavations led by Egyptologist Mark Lehner uncovered a vast workers' settlement just south of the Giza Plateau. Instead of chains and prison cells, researchers found barracks, bakeries, breweries, kitchens, workshops, and even cemeteries where laborers were buried with honor near the pyramids they helped construct. Analysis of animal bones suggests these workers consumed surprisingly nutritious diets that included beef, sheep, and goats, requiring thousands of pounds of meat every day. But how did they do it? And why? Well, this is where the mystery quietly changes. The engineer's puzzle. Engineers looked at millions of carefully fitted stones, enormous granite blocks weighing up to 70 tons, and construction tolerances that still impress modern surveyors, then asked a deceptively simple question. Exactly how was all of this accomplished? Over the last century, that question has inspired dozens of competing engineering models. For generations, the leading explanation involved massive external ramps stretching up the sides of the pyramid. It sounds reasonable until the numbers begin to grow. To maintain a practical slope capable of dragging multi-ton blocks, a straight ramp reaching the summit may have needed to extend well over a mile and contain an enormous volume of stone and mud brick, possibly rivaling the pyramid itself. That raises difficult logistical questions. Who built such a ramp? How long did it take? And where did it go afterward? Archaeologists have proposed alternatives, including zigzag ramps climbing the pyramid's faces, spiral ramps wrapping around the exterior, and combinations of shorter ramps used during different construction phases. Each model solves certain problems, but it ends up introducing new ones. In the late 1990s, French architect Jean-Pierre Houdin suggested that the builders constructed a relatively short external ramp for the lower portion before switching to a spiral ramp hidden within the pyramid itself. According to his model, workers hauled blocks upward through an internal corridor just beneath the outer casing, turning at open corners before continuing toward the summit. The theory gained additional attention after muon imaging projects and other non-invasive surveys revealed previously unknown voids within the Great Pyramid. Although none of those discoveries confirmed Houdin's proposal, they demonstrated that significant hidden spaces still exist inside the monument. Another unconventional idea approaches the puzzle from an entirely different direction. French materials scientist Joseph Davidovits proposed that many of the pyramid's limestone blocks were not quarried as solid stones at all, but instead cast in place using an early form of geopolymer concrete. Rather than dragging every block across the plateau, workers may have mixed crushed limestone, clay, lime, and water before pouring the material into wooden molds. Supporters point to certain microscopic features within some stones, that they argue resemble artificial composites. Most Egyptologists remain unconvinced, noting extensive quarry evidence around Giza, unfinished blocks, tool marks, and transportation records that strongly support traditional stone quarrying. Even so, Davidovitz's hypothesis continues to attract attention. The debate becomes even more intriguing inside the granite itself. Engineers have long examined drill cores, circular boreholes, saw marks, and polished granite surfaces recovered from Egyptian sites. During the 19th century, pioneering engineer Sir William Matthew Flinders Petrie documented several of these features, including spiral grooves inside granite drill cores that appeared remarkably regular. Later writers argued the markings implied cutting speeds or machining techniques beyond what copper tools could achieve. Modern experimental archaeologists disagree, demonstrating that copper drills combined with hard abrasives such as quartz sand can gradually cut granite with surprising efficiency. Yet reproducing every ancient mark remains challenging. Or maybe they had access to sophisticated knowledge that just disappeared. Roman engineers, for instance, developed a volcanic concrete that has survived nearly 2,000 years in harsh marine environments, yet its precise formulation was forgotten for centuries before modern scientists began unraveling its chemistry. Greek fire terrified medieval navies with its seemingly unstoppable flames, but the exact recipe vanished from history. Damascus steel became legendary for blades whose manufacturing techniques remain only partially understood today. These examples demonstrate that highly specialized craftsmanship can flourish, fade, and eventually become difficult to reconstruct. Or maybe it's something else entirely. Messages hidden in stone. The deeper researchers explored the Great Pyramid, the more some of them became convinced that its secrets were not hidden in chambers or passageways, but in numbers. Long before laser scanners and computer models, surveyors noticed relationships between the pyramid's dimensions that seemed almost too elegant to be accidental. Engineers debated ramps, archaeologists studied tools, but mathematicians and astronomers began asking an entirely different question. What if the monument itself was a message? It was a seductive idea, and over the last 2 centuries, it has inspired some of the most fascinating theories ever proposed about the pyramids. Among the most influential is the Orion correlation theory, introduced in the early 1990s by Belgian-born engineer Robert Bauval. He argued that the positions of the 3 main pyramids at Giza mirror the 3 stars of Orion's belt, a constellation deeply connected with Osiris, the Egyptian god of the afterlife. Bauval also suggested that the Nile represented a terrestrial counterpart to the Milky Way. Ancient Egyptian texts unquestionably link the pharaoh's soul with the stars, and several pyramids contain shafts aimed toward specific celestial objects. That much is well established. The debate begins when those symbolic connections are transformed into claims of precise astronomical planning. Critics argue that the pyramid arrangement only approximately resembles Orion's belt, and that similar patterns can emerge when enough stars and landmarks are compared. Besides this, one of the oldest claims surrounding the Great Pyramid concerns the number pi. Measure the pyramid's original perimeter, divide it by twice its original height, and the result comes remarkably close to the mathematical constant. Supporters argue this cannot be accidental. Skeptics counter that the relationship naturally emerges from the pyramid's chosen slope, and that no surviving Egyptian text states the builders deliberately encoded the constant. The Rhind mathematical papyrus, copied centuries later, certainly demonstrates that Egyptian scribes possessed sophisticated practical mathematics, but whether that knowledge included an intentional approximation of pi within the pyramid itself remains an open question. Not far behind comes another familiar number, the golden ratio, often represented by the Greek letter phi. Books, documentaries, and internet discussions frequently claim that the Great Pyramid embodies this famous proportion. Depending on which measurements are selected, the ratio between the pyramid's sloping height and half its base appears surprisingly close to phi. Yet, This is where the discussion becomes considerably more complicated. Different researchers choose different dimensions, producing slightly different results, and there is no ancient inscription declaring that the golden ratio held special significance for Old Kingdom architects. Some mathematicians caution that when thousands of measurements exist within a structure, intriguing numerical relationships are almost inevitable. Others believe the recurring appearance of elegant proportions deserves further investigation. The numbers themselves are real. Their intended meaning remains far less certain. Then there are the coincidences that seem almost impossible at first glance. One of the most widely shared claims points to the Great Pyramid's latitude of approximately 29.9792 degrees north, noting its resemblance to the speed of light expressed in meters per second, 299,792,458. For many people, the similarity is astonishing. Yet others point out that this comparison depends entirely on modern units of measurement, decimal notation, and contemporary geographic coordinate systems. These did not exist in ancient Egypt. Change the units or alter the mapping standard, and the apparent connection disappears. Other researchers have gone even further, suggesting that the pyramid preserves hidden knowledge about the Earth itself. Various authors have argued that its dimensions encode the planet's circumference, the length of the polar radius, the precession of Earth's axis, or other geophysical measurements. Some connect these ideas to sacred geometry, the belief that certain mathematical forms possess symbolic or even spiritual significance throughout the universe. There is little doubt that ancient Egyptian architects relied heavily on geometry to survey land, establish right angles, and orient monumental structures with extraordinary accuracy. Whether they intentionally embedded global measurements into the pyramid is another matter entirely. No surviving Old Kingdom texts describe such ambitions, yet the remarkable precision of the monument continues to encourage new interpretations generation after generation. Perhaps that is the most enduring aspect of the Great Pyramid. Every measurement seems capable of telling more than one story. One observer sees brilliant engineering. Another sees celestial symbolism. Another finds mathematical elegance, while someone else sees coincidence shaped by the human tendency to recognize patterns. The ancient Egyptians unquestionably observed the heavens, tracked the movements of stars, and incorporated astronomy into their religion and architecture. What remains uncertain is how far they intended those connections to extend. Were they building an eternal royal tomb? A cosmic monument? A mathematical masterpiece? Or something that blended all three? Well, they can't tell us, at least not in person. The civilization that vanished. The mystery deepens just beyond the Great Pyramid, where another monument has fueled one of archaeology's longest-running debates. Carved directly from the limestone bedrock of the Giza Plateau, the Great Sphinx has watched over the pyramids for more than 4,000 years. Most Egyptologists date it to the reign of Pharaoh Khafra during the 4th dynasty, around 2500 BCE. Yet, in the early 1990s, geologist Robert Schoch proposed a different interpretation. After examining the erosion patterns on the Sphinx enclosure, he argued that portions of the weathering appeared more consistent with prolonged rainfall than with wind and sand alone. If correct, that would imply the monument, or at least parts of its enclosure, could predate the Old Kingdom by thousands of years, reaching back to a time when Egypt's climate was far wetter. Schoch's proposal challenged one of the foundations of Egyptian chronology. Most geologists and Egyptologists, however, reached different conclusions. They argue that the erosion can be explained by a combination of salt, crystallization, groundwater, natural weaknesses in the limestone, and thousands of years of weathering after the monument was carved. Archaeological evidence also links the Sphinx closely with Khafra's pyramid complex, supporting the conventional date. Even so, the debate introduced a question that would echo far beyond the Giza Plateau. If the accepted timeline could be questioned in one place, Other assumptions about prehistory might also deserve another look. That question gained momentum with growing interest in the Younger Dryas, a dramatic period of climatic change beginning around 12,900 years ago. During this interval, temperatures in parts of the northern hemisphere dropped sharply before warming again roughly 1,200 years later. Scientists continue to study its causes and consequences, including evidence for massive meltwater floods, changing sea levels, and widespread environmental disruption. While the Younger Dryas itself is well supported by geological evidence, the extent of its impact on early human societies remains an active area of research. It became fertile ground for broader speculation because it offered a real prehistoric event around which more extraordinary narratives could be built. Adding to the intrigue were flood traditions preserved by cultures separated by vast distances. Ancient Mesopotamia tells of Utnapishtim in the Epic of Gilgamesh. The Hebrew Bible recounts Noah's Ark. Greek mythology speaks of Deucalion, while many indigenous cultures across the Americas, Asia, and Oceania preserve stories of catastrophic floods. Historians generally view these accounts as independent traditions shaped by local experiences with flooding. Nevertheless, the recurring theme has inspired generations of writers to wonder whether distant memories of ancient environmental disasters survived in myth long after the events themselves. Then, in southeastern Turkey, archaeologists uncovered a discovery that genuinely surprised the academic world. Excavations at Göbekli Tepe, led by German archaeologist Klaus Schmidt, beginning in the 1990s, revealed massive stone enclosures dating to approximately 9,600 BCE, thousands of years older than Stonehenge and predating agriculture in the region. Decorated with carved pillars depicting animals, the site demonstrated that prehistoric hunter-gatherers were capable of organizing large-scale construction projects far earlier than many researchers had once assumed. It was against this backdrop that author Graham Hancock advanced one of the most widely discussed alternative hypotheses of recent decades. He proposed that an advanced Ice Age civilization existed before the end of the last glacial period, and that survivors passed fragments of their knowledge to later cultures, including the ancient Egyptians. He points to sites such as Göbekli Tepe, global flood traditions, astronomical symbolism, and unresolved questions about early civilization. He sees them as pieces of a larger puzzle. Archaeologists counter that, despite decades of investigation, there is no direct evidence of cities, writing, metallurgy, or other material remains from such a civilization. The idea itself stretches back much further than modern books. In the 4th century BCE, the Greek philosopher Plato described Atlantis as a powerful island civilization that supposedly disappeared beneath the sea after a catastrophic event. Most classical scholars regard the story as a philosophical allegory rather than historical fact. Yet Atlantis has inspired countless interpretations for more than 2,000 years. Ancient Egyptian texts also describe a distant sacred past known as Zep Tepi, or the first time, when the gods were believed to have established order before the reigns of human kings. Whether viewed through geology, archaeology, mythology, or speculation, one fact remains clear. These ideas have captivated millions because they attempt to answer genuine mysteries with a single sweeping explanation. This leaves us with perhaps the most compelling question of all. If an advanced civilization truly existed, where did it go? From gods, to aliens, to artificial intelligence. During the 19th century, Europe and America experienced a surge of fascination with ancient Egypt. Napoleon Bonaparte's expedition to Egypt between 1798 and 1801 introduced thousands of sketches and scientific observations to the Western world, while the decipherment of hieroglyphs by Jean-François Champollion in 1822 unlocked a civilization that had remained largely silent for centuries. Yet, alongside legitimate archaeology emerged a very different movement. Writers such as Ignatius L. Donnelly connected Egypt to Plato's Atlantis, while others claimed the Great Pyramid concealed divine measurements, biblical prophecies, or sacred knowledge intended for future generations. Figures like Charles Piazzi Smythe, Scotland's Astronomer Royal, argued that the pyramid encoded the dimensions of the Earth and even predicted major historical events. The 20th century introduced an even more extraordinary possibility. If ancient civilizations seemed incapable of constructing monuments of such scale, perhaps someone else had helped them. In 1968, Swiss author Erich von Däniken published Chariots of the Gods, arguing that many of humanity's greatest achievements were influenced by extraterrestrial visitors. The Great Pyramid quickly became one of his most famous examples. Von Däniken pointed to its immense precision, the transportation of massive stones, and unanswered construction questions as evidence that advanced beings may have shared knowledge with ancient Egyptians. His books sold millions of copies worldwide and inspired countless documentaries, television programs, and debates. Not every unconventional theory looked toward the stars. Manufacturing engineer Christopher Dunn approached the pyramid through the lens of modern industry. After years of studying precision machining, he proposed that the Great Pyramid functioned not as a royal tomb, but as a sophisticated power plant. Dunn argued that the king's chamber, the grand gallery, and the granite-rich interior formed part of an enormous machine capable of generating energy through resonance, hydrogen reactions, and microwave phenomena. His books attracted engineers and science enthusiasts intrigued by the monument's remarkable precision. Critics, however, note that no archaeological evidence has revealed electrical components, energy distribution systems, chemical residues consistent with such reactions, or Egyptian texts describing the pyramid as anything other than part of a royal funerary complex. Closely related are the growing number of acoustic and resonance theories. Researchers have measured unusual sound properties inside chambers of the Great Pyramid, particularly within the King's Chamber, where certain frequencies resonate more strongly than others. These observations are genuine and have been documented in scientific studies examining the acoustics of enclosed stone spaces. From there, however, interpretations begin to diverge. Some suggest these resonances were simply natural consequences of the chamber's dimensions, while others speculate they played ceremonial or symbolic roles during ancient rituals. More ambitious claims propose that sound itself was central to the pyramid's purpose, though direct archaeological evidence remains absent. Once again, measurable phenomena exist, but their significance remains open to interpretation. Then came the Internet. And now, another chapter is unfolding. What did Grok say, and what does it actually mean? So, what happens if we ask artificial intelligence to decide? At first glance, the answer seems almost irresistible. An AI can process vast amounts of information in seconds, summarize centuries of research, compare competing arguments, and present its conclusions with remarkable confidence. To many people, that confidence sounds like certainty. Many on the internet have claimed that language models such as Grok uncovered hidden truths about the pyramids simply by analyzing existing information. But before accepting or rejecting those conclusions, it is worth asking a more important question. What exactly is an AI doing when it answers? Let's return to the evidence. Archaeology provides strong support for Khufu's involvement through quarry marks inside the relieving chambers, the workers' settlement at Giza, and Merer's diary describing limestone deliveries to the construction site. Engineering continues to debate precisely how the monument was assembled, but not whether the ancient Egyptians possessed the organizational ability to build it. The internal ramp theory remains an intriguing possibility, rather than an established fact. The geopolymer hypothesis continues to divide materials specialists, but has not displaced the quarry evidence. Orion's belt reflects genuine Egyptian interest in astronomy, although whether the pyramids intentionally mirror the stars remains disputed. The Sphinx weathering debate continues among geologists, while Hancock's Ice Age civilization and ancient astronaut theories remain unsupported by direct archaeological evidence. Each theory contains pieces grounded in observation, but the strength of the evidence varies dramatically. One reason these ideas remain so compelling is a psychological tendency known as confirmation bias. Humans naturally notice information that supports what they already suspect, while paying less attention to evidence that points in another direction. Someone convinced the pyramids conceal advanced mathematics may focus on geometric relationships, while overlooking simpler architectural explanations. Someone expecting evidence of a lost civilization may connect flood myths, Göbekli Tepe, and the Sphinx into a single narrative, while treating the lack of direct archaeological remains as less significant. Confirmation bias is not unique to fringe theories. It even affects scientists and historians just as much as everyday people. The difference is that science attempts to reduce that bias by testing competing explanations against all available evidence, rather than only the evidence that appears supportive. Mathematics provides another fascinating example. The Great Pyramid contains thousands of measurable dimensions, angles, heights, and distances. With so many numbers available, surprising relationships are almost guaranteed to appear. Some closely resemble pi, others approximate the golden ratio, while still others seem to correspond with Earth's dimensions or astronomical cycles. Statisticians call this the multiple comparisons problem. When enough measurements are examined, meaningful-looking patterns inevitably emerge, even if they were never intentionally designed. That does not automatically mean every numerical relationship is accidental, nor does it prove that every apparent discovery reveals hidden knowledge. The challenge lies in distinguishing deliberate design from coincidences that become visible only after generations of searching. This brings us back to artificial intelligence. A language model does not conduct archaeological excavations, discover new inscriptions, or perform independent geological fieldwork. Instead, it generates responses. And how does it do that? Well, it recognizes patterns within the information on which it was trained and follows the instructions it receives. That distinction matters. Ask an AI, "Who built the pyramids?" and it will likely summarize the archaeological consensus. Ask, "Present the strongest evidence that a lost civilization built the pyramids," and it may produce a persuasive argument supporting that position. Ask it to defend the ancient astronaut hypothesis, and it can do that as well. The underlying historical evidence has not changed. Only the task has. This difference between evaluating a claim and defending one is often overlooked. Imagine asking a lawyer to argue for a client's innocence regardless of personal belief. A skilled attorney can construct a convincing case without proving the client is actually innocent. Language models operate in a similar way. They excel at organizing information into coherent narratives, explaining competing viewpoints, and even role-playing hypothetical positions. If prompted to advocate for Atlantis, aliens, or forgotten technologies, they can produce fluent, compelling explanations. If asked instead to compare all major theories according to the quality of supporting evidence, the response usually becomes far more balanced. The AI has not changed its mind because it never possessed one in the first place. It simply followed a different set of instructions. That realization may be the most important lesson of all. It's remarkable just how easily convincing narratives can emerge when questions are framed in particular ways. A carefully worded prompt can produce an argument for almost any position, especially when the subject already contains genuine mysteries, incomplete evidence, and centuries of speculation. Confidence should never be mistaken for proof, whether it comes from a best-selling author, a viral video, or an artificial intelligence. Yet none of this diminishes the Great Pyramid itself. Engineers still debate aspects of its construction. Archaeologists continue to uncover new discoveries, from hidden voids revealed through muon imaging to ancient papyri that deepen our understanding of Old Kingdom logistics. Future excavations may answer questions we cannot resolve today, while undoubtedly raising new ones. The Great Pyramid remains one of humanity's greatest achievements, regardless of whether its builders used external ramps, internal ramps, or methods yet to be fully understood. Perhaps that is the monument's greatest legacy, Not that it conceals impossible secrets, but that more than 4.5 millennia after its construction, it still challenges every generation to ask better questions and to search for better answers. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.